Are there any questions on 3.3 that I need to answer before we move on? I was able to do the homework. Looks like most of them got in. Most of them turned them in. At least I think. Yeah, let's see, everybody turned it in except for, no, everybody's turned them in. We're good. Okay, so let's get going. Oh, Lila's in the waiting room. Okay. So we're going to do 3.4 today. We are on page 283, properties of logarithmic functions. Properties of logarithmic functions. If you look in the middle, there's a blue box there on page 283. Gives you the product rule, the quotient rule, and the power rule. Log of b base b r s is equal to log b r plus log base b s. The quotient rule would be log b r minus log b minus bs. Okay, and then there's the power rule, which says that log b r to the c. If you had a c here, the c would go forward. C log b of r. Okay, pretty simple stuff, right? And is this the first time you guys seen this, or have you seen this before? This is the first time you guys seen this, correct?
I think so.
Okay, all right, okay. Well, as far as Ezekiel is concerned, it is the first time he's seen it. All right. Example number 1, and we're not going to prove that. It's simple. Let's go to example number 2. Expanding the logarithm of a product. Let's see if we can do this and get kind of used to how to use the properties that we just learned. So we have log of 8xy to the 4th. Okay. So Hunter, why does this not have a base here?
What for the
log? There's no base.
I don't know, because it doesn't have a base.
How can you not have a base?
I don't know.
Brady, why do you not have a base?
Isn't it just 10?
Yes.
If it does not have a base, it means it's 10, right? It's a common log. So the common log is base 10. And so there is a 10 base here, you're just not seeing it, okay? Good work. Okay, so this is the same as log of 8 plus log of x plus log of y to the 4th. Everybody follow, right? Because they're all multiplied together and they're basically the same as adding the separate logs together, right? That was the first rule. Okay. However, we can go further here and say that 8 is 2 to the 3rd power. And now I can bring these down. I can say this is the same as 3 log of 2 log of x. The 4 will come over, 4 log of y. Okay? It's kind of nice looking, right? All right, so that's example number 2. Example number 3. Example number 3. Example number 3, we are going to expand the logarithm of the quotient. So we want to rewrite natural log of square root x squared plus 5 over x. Okay, as a sum or difference of logarithms or multiples of logarithms. Okay? So the very first thing that we do is we convert this guy and say this is the same. What? Oh, never mind. So it's going to be x squared plus 5 over x, like that. Okay, so first thing we're going to do, we're going to use the quotient rule, and we're going to say this is the same as natural log of a square root of x squared plus 5 minus natural log of x. Okay? Because that's why it's this guy divided by this, so it's this guy minus this. Okay, now this is going to be, now you can call this to the 1/2. So you can move the 1/2 down now and say 1/2 natural log of x squared plus 5 minus natural log of x. Okay, what can I do with this? X squared plus 5 in a natural log, I can change that to Brooklyn.
What are we changing?
This one in here, the first one. X squared, the natural log of x squared plus 5.
I don't know.
Trick question, you can't change it, right? Because it's a plus, right? If it was a multiplication, we could change it, but it's a plus, so you can't do anything with this. You're done, really. Okay, all right. Okay, so that's that. Example number 4. Example number 4. Considering condensing. Assume that x and y are positive, write into a single logarithm. So I have natural log of x to the 5th minus 2 natural log xy. Okay, right as a single logarithm. So if I do that, I'm going to go ahead and use the quotient rule first. Natural log of, well, actually, no. I'm going to go ahead and put the 2 and move it back over here like that. So then I'm going to combine it. I'm going to be x to the 5th, x squared, y squared, natural log of x to the 3rd over y to the 2nd. Okay, all right, does that make sense? Are we good? Because I'm going to go ahead, this goes away and this becomes 3. Okay, so that's that. And then last but not least, we have the good old change of base rule. The change of base rule says that if I have a logarithm that looks like a of b is the same as natural log of c, natural log c a. Okay, so I can change the base. It's called the change of base rule because I changed the base from A's to C. Okay, in other words, if I had the natural log of, let's say a natural log of 4 would be the same as log 4 over log, what would I put here? What would be down in here? Anybody? It would be the base, right? What's the base here? What's the base of this guy?
10.
E, right?
My bad.
Does that make sense? Does that make sense? So let's go, if I had log base 3 of 5 would be the same as natural log of 5 over the natural log of what? We'll go here.
Natural
Yeah.
log 3.
3, it'll be 3, right? There you go. Okay, all right. So I changed the base from 3 to natural log. I changed the base from natural log to common log. Can you see that? You see why it's called the change of base? Okay, all right. And that would be the bottom of page 285 in the blue box. That would be the change of base rule. Okay, so that is the change of base rule. See if there are any. We have example number 5. So let's do example number 5. Example number 5, evaluating logs by changing the base. So I have log base 3 of 16. So I would use the common log here, 3, okay? So I can further go what? 16 is 2 to the 4th. Are they doing that in the book? Are they changing that? They're not. Okay, never mind. Actually, they're changing it to a natural log. That doesn't matter. So it's natural log of 16, natural log of 3, right? B, we have log base 6 of 10, and they're changing this to a common log. So it's going to be log of 10, log of 6. Log of 10 is 1, right? Because it's a common log, 1 over log of 6. Okay? And then we have, last but not least, log of 1/2, 2. Okay, and we are changing this to natural logs, natural log of 2. Natural log of 1/2. 1/2 is the same as 2 to the -1, right? Because it's the reciprocal number, right? So it's -1. -1 goes forward. It becomes natural log of 2, negative natural log of 2. These two cancel out. -1, which makes sense, right? Because if you look at this, this is the same as 1/2, and 2 is 1/2 -1, right? Because 2, again,
Mr. Ron,
yeah.
for example 5B,
Uh-huh.
they didn't change it to natural log.
They changed it to a common log. Why do you think they changed it to a common log there? The reason why they use common log is because you have on the numerator, you have a 10, right? So they knew that you're going to go, it's going to be log 10 of 10, which becomes 1, right? That's probably why they did it. There is no really rhyme or reason why they did it, okay? It just said evaluating logarithms by changing the base, because you can change the base really for whatever you want, right? You could have said log of 10, log base 610 is going to be the same as log 8 of 10, log 8 of 6, right? I mean, if you really wanted to, I mean, problem is that you don't gain anything from going from here to here, right? Unless you just happen to know what log base 8 of 10 was, right? So in your calculator, you can go ahead and just evaluate this without having to change base. So there really is no, it's just kind of seeing if you can actually notice what's going on here. That's all they're doing, really. Okay, are we good? Any other questions? All right, we'll stop here in the first half, and then we will complete the second half later.